Tree diagrams can be used to list all of the outcomes of a particular probability event, especially when we've got more than one event. So in this first example, we're going to toss a coin and roll a six-sided dice. So this is how we draw the tree diagram. It doesn't matter whether we start with the coin or the dice. I'm going to start with the coin. So let's say on the coin we could have got a head or we could get a tail. So they're our first branches. If we got a head, what could we get on the dice? Well, we could get a 1, get a 2, a 3, a 4, a 5, or a 6. If we got a tail with the coin, we could still, with the dice, get a 1, a 2, a 3, a 4, a 5, or a 6. So there we have all of our different outcomes listed. For example, we have got a head and a 1, a head and a 2, a head and a 3, etc. A head and a 4, a head and a 5, a head and a 6, a tail and a 1, tail 2, tail 3, tail 4, tail 5, tail 6. That means there are 12 different outcomes. So then if we're asked a question such as, what is the probability of tossing a head and an odd number? So let's look at where we get those. A head and a 1, that's a head and an odd number, a head and a 3, or a head and a 5. They're the only ways we can get head and an odd number. So that is 3 ways out of 12 different ways. So the probability is 3 out of 12, or we could say that's the same as 1/4. Now in this instance, I drew my heads and tails, my coin first. I would get exactly the same results if I started with the dice. So I could say, when I roll my dice, I can get a 1, a 2, a 3, a 4, a 5, or a 6. Let's say I got a 1 with my dice. Then I could get a head or a tail with the coin. Same if I got a 2, I can get a head or a tail with the coin, and so on. And again, we will come up with exactly the same 12 different outcomes. So it doesn't matter which order you do those in. Just looking at